Hello, my name is Tiago de Moraes. I'm professor at the Universidade Federal de Minas Gerais. And in this poster, I will talk about inverse Laplace transform for signal analysis of low field nuclear magnetic resonance. The goal of the poster is to present a recent paper where I described the fundamentals of the inverse Laplace transform, where from a time domain signal after the ELT process, we obtain a distribution, for example, of relaxation times. And the scripts and the codes that we developed are available for free for teaching, learning, research, and other educational purposes. Typically, there are several experiments in low field and even in high field NMR that we obtain curves of exponential growth or exponential decay as the inverse recovery pulse sequences, CPMG, B-dimensional experiments, diffusion experiments in low or high resolution NMR. And this type of signal we need to process to obtain the rate of these decays, like the diffusion coefficient or the T2 relaxation times. And the inverse Laplace transform is important for samples that we have a broad distribution of relaxation times, for example. For simple samples, mono-exponential fitting or bi-exponential fitting can be enough to determine 1, 2, or 3 components in an experimental signal. However, for more complex samples as foods, rocks, we can have actually a distribution of relaxation times in a complex sample. And the inverse Laplace transform will obtain this correct interpretation of the NMR data. There are several methods to perform this inverse Laplace transform. Some of the softwares come with the spectrometers, others are free to use, like these ones. And in this paper, we present a script that works inside the OriginLab software, where from your data, you can analyze it with our script and you obtain results like this. It's just these two columns, but also we provide the singular values, the composition, a visualization of the fitting of the signal, residues, and so on. In their paper, there are also discussion about the regularization parameter alpha and the sensitive of the method to noise, and also some discussions with simulated signals as with 2 components or more components, more broad lines, narrow lines for CPMG, inverse recovery, saturation recovery, several different situations. And also we present some results with real NMR data as for foods, polymers, and other complex samples that we have analyzed and published in some recent papers. So I would like to thank you, Aurem, Universidade Federal de Minas Gerais, and Rafael Fenerick, who worked in this project with me. This is the paper, I am talking about, and in my YouTube channel, in this playlist, you can have access for some video classes where I teach how to use this code, how to install it in your computer, and some tips about the inverse Laplace transform. Thank you.